Okay, problem number 2 for free fall, where the ball is thrown straight up. Again, let's start with a picture. Here's our start point. It goes straight up, and it ends here. I'm going to call positive y up. It makes the most sense this way. So let's see what we know. We were told it is thrown up at 16.3 meters per second. Now the velocity at the peak must be 0 because the ball has to stop because it can't go any higher. If it didn't stop, it would keep going up. So 0 meters per second at the end. So let's start making our list of things we know. We know V0, 16.3 meters per second. We know V, 0 meters per second. Anytime you know V0 and V, we should immediately feel that we should know V bar, especially when one of the velocities is 0. So taking the average of the two numbers, 8.15 meters per second. So let's look at the acceleration. Freely falling object. However, this time we chose y up, and remember, g points down. So they're opposite in direction, therefore they must be opposite in sign. So it's negative g, or negative 9.80 meters per second squared. Remember, it is not negative because the ball is going up. It is negative because our axis is pointing up. And what we are looking for is delta y. And the other thing we don't know is t. So let's see what we can do. We have one equation that we can use to solve everything. V squared equals V0 squared plus 2a delta y. Solving for delta y. V squared minus VO squared over 2a. So we can finish this. Delta y, 0 squared minus 16.3 meters per second squared over 2 times negative 9.80 meters per second squared. As we look, we're going to have a negative on the top and a negative on the bottom, which will cancel. And we end up with delta y as 13.6 meters. And that's our answer. And our quick check, delta y is positive. We called positive y up. They agree in sign, which makes sense for this problem.